Yes, Kundan, good evening. And Abhilash, good evening. Kundan, okay, yeah. Is it audible now? Everything going good? Just confirm whether the audio, video, everything is fine or not. थोड़ा हाइट ज़्यादा है शायद, थोड़ा नीचे करना हो. हाँ अभी सही. राइट राइट. पार्ट 1 नहीं आ रहा है थोड़ा. थ्योरी ऑफ कंप्यूटेशन. थोड़ा और होगा. हाँ नाउ इट्स फाइन. और या सर थोड़ा पार्ट हट रहा है, नीचे नहीं आ रहा है, स्क्रीन पूरा नहीं. I think वो there is a delay in that, right? Maybe just check this whole screen is visible. Okay now. Yeah guys, just give us a minute, we'll cross check. Yeah, everything fine. Yeah, thank you so much. Yeah, so okay, so yes, I think this, like this part is this part, like Mr. Amit Goyal, this ये चुप रहा है. Is it? No, ये तो नहीं रखी. So yes guys, so we'll start the session now. Just everybody can confirm, somebody can confirm, audio, video, everything is fine. Can you guys just confirm once? Yes, Kundan, recursive enumerable languages are not close under complement. It's very clear. I even told yesterday also. Yeah. Okay. Yes, sir. Saurav, yes, very good evening. Vijay, yes, sir, perfectly fine. Atul, yes, good. Okay, so let's proceed further. Yeah. So I think I'll start from where we left yesterday, and I hope today we'll cover all the remaining topics that we have in theory of computation, right? So let us start with the let's start to try to understand where we were yesterday, and then see what else needs to be done today, right? So I think what we covered yesterday. So can the guys comment what we covered yesterday so that I get to know you all were there? Yes, thanks Tejasvi. Yeah, so just comment. Okay, yes Kundan, you're correct, we covered decidability yesterday. Decidability was covered yesterday. What else we covered? Identification of the class of the language. So again, as I said yesterday also, these are the two topics from which at least one question is coming from the last 4 to 5 years. Identification of the class of the language. Right? Now, we started with the closure properties, and we will complete the closure properties today itself. And we will start the remaining topics also. So guys, what are the remaining topics? What are the remaining topics that we need to cover? And which are important too, as we discussed, we are discussing the most probabilistic questions that are going to be asked in the GATE exam. So any ideas? So what are the remaining topics? Yeah, so I think correct, Gundan, you are correct. So what we will do is today is we will cover the finite automata. Again, as you said, Kundan, this is regular expressions are a part of finite automata. We'll cover it in detail today. Second is the push down automata. We'll cover that also today. Then we have the Turing machines. We will also cover them today, right? And all this combinedly, as I said, all this gives you around 2 to 3 questions in the gate in the current times. This part gives you 1 to 2 questions, thereby making the whole weightage as 3 to 5 questions, right? So let us discuss this part today in detail, and I hope now everyone understands. Yes, Abhilash, push down automata, the context free grammars will go into the push down automata itself, right? And what else you wrote? You wrote Turing machines, finite automata, yes, and okay, of course, regular expressions. So CFGs will be a part of the push down automata itself, right? So that we will cover over there. Okay? Yeah, so the pumping lemma also goes into the finite automata itself, right? Okay, so these are basically the important topics which we'll cover today in the next 3 hours, and I hope this will give you enough confidence to attempt all the questions that come in the GATE exam, right? So let's start with the things today. First of all, regarding closure properties, we discussed just one question on closure properties in the last class. Now, before going to the questions further, I'll briefly discuss the theory so that those who do not know the theory also are also able to catch up with us. And for those who already know, it will be a brush up of the things. We'll do a brush up within the next 5-10 minutes, right? So let's see how the closure property stands with each types of languages. So what are the so when we say closure properties, what do we mean? We basically mean that whenever we apply an operation on a language, that once after that operation is applied, whether we get back the same kind of language or not, the same class of language or not, if we get the same class of language, we will say that the language is closed, right? So let us see, for example, when we apply complementation on a regular language, we get back the regular language, we say that the regular languages are closed under complementation. If we take intersection of two regular languages, the language that we get is again a regular language, therefore we can say that the regular languages are closed under intersection. So let's see what are the various operations and what is how we arrange them, how do we see what is their behavior on the various properties, whether they are closed or not on the various operations, right? So okay, yeah, so Jagdish, yes, good evening Jagdish. So let's see what are the various properties. So we have union, intersection, set difference, complement, union, intersection, set difference, complement, then intersection with the regular language. So those who do not know this can kindly note it down parallelly, or you can take a snapshot also if you like. And those who know this, they can just revise up what we are discussing right now. Intersection with a regular language. Okay. So these are the 5 properties that we will talk about. What are the other properties? We have concatenation, we have clean closure, we have clean plus, then we have reversal, right? So these are the properties. Yes, good evening Nikhil. So then we have, so how many properties we need? 9. So then we have something called as homomorphism, abscilline free homomorphism, then we have inverse homomorphism. So by these commas, I mean you'll copy what is written above. I hope you all know this. Inverse homomorphism, then we have substitution, then we have epsilon free substitution, and then finally subset operation, the subset. So these are all the 15 properties. If you remember these properties, believe me, you'll be able to solve all the questions that are asked, that have been asked till now, or they and we believe that in future also most of the almost all the questions can be answered using these properties, right? So let's see how does each and every language behaves on these operations, whether they are closed or not. Let's see. Let's try to find it out, right? So when we talk about regular languages, they are closed under all the operations except the subset operation. So when I say tick, tick simply means that operation is closed under that language. So let's see, regular language is closed under all the operations we discussed as I just suggested. So regular languages, they are closed under almost all the operations except the subset operation. Except the subset operation. Right? So that's one thing. So regular languages are closed under all the operation except the subset operation. Right? So is it okay, guys? So regular languages are closed under all the operation except the subset one. Also in infinite union, yes, of course, in infinite union they are not closed, you are correct. So also in infinite intersection also they are not closed. So again, Abhilash, I am taking out the basic operations. There are certain operations which are not basic, you can think upon based upon the logic. So basic operations which you keep in mind, if you are able, based on that you will be able to answer almost all the questions, right? Okay. So coming back to context-free languages. So context-free languages, they are closed under all the operations except intersection, set difference, and complement, right? So intersection, set difference, and complement, they are not closed. Otherwise, they are closed under all the operations. The context-free languages. So these are regular languages. These are context-free languages. So context-free languages, they are closed under all the operations except, as I said, union, intersection, set difference, and complement. Again, subset is not again closed. Subset is again not closed. Right? So subset operation, it's not closed under any of the languages because the subset can be anything, right? So let's see the other class. So then we have so as I said, you just need to remember this fact, and based on this fact you would be able to remember the entire column for context-free languages, right? Now let's move to the deterministic context-free languages. Deterministic context-free languages. So these languages are basically closed only under 3 operations. They are basically closed under 3 operations, and what are those operations? One is complement, other is intersection, and they are also closed under inverse homomorphism. They are also closed under inverse homomorphism. Under and rest all of the operations, they are not closed. So yeah, they are not closed. DCFLs, sorry. So DCFL, DCFL. So as I said, they are only closed under inverse homomorphism and rest of all the operations, they are not closed. DCFLs, right? So let's see over here, they are closed. They are not closed under any of the other operations, right? Yes. So you just need to remember three facts, that complement, intersection with the regular language, and inverse homomorphism, as I suggested, right? So this is all about regular languages, context-free languages, and then we have the determinative context-free languages, right? Now next part is we have recursive languages and context-sensitive languages. They have the same behavior, therefore I'll write them together, right? So recursive languages and context sensitive languages, they have the same behavior, and their behavior is they are not closed under homomorphism and substitution, otherwise they are closed under all the operations. So let's see how the table looks like. They are closed under all the operations. So we have recursive languages and we also have context sensitive languages. So they are closed under all the operations except homomorphism and substitution, as I suggested. Recursive languages and context sensitive languages, homomorphism is not closed and substitution is also not closed. Apart from this, all other things are closed. And even subset, as I said, it's not closed anywhere, right? So what you need to remember is just three facts, that they are not closed under substitution, and then homomorphism, and then subset, right? And subset you can remember at once because it's not closed anywhere. Even if when we discuss the other class, we will get to know the last class, even there it is not closed. Okay? So the last part is recursive enumerable languages. Recursive enumerable languages. What is the behavior in recursive enumerable languages? They are not closed under only two operations. Again, I'm not counting subset because it's not closed anyways. Any of the language is not closed there. And other operations there, they are not closed, are complement and set difference, right? So let's see. Everywhere they are closed. So this is fine. And then we have this. Recursive enumerable languages. So they are closed everywhere. And then we have recursive enumerable languages. So they are not closed under, as I said, set difference and complement. Apart from this, everywhere they are closed, right? That's all about the closure properties. If you remember this much summary, you will be able to understand all of these things, right? Correct. I said the same thing. Yes, Abhilash, you are correct. No, they are not closed under set difference in the complement operations, right? So I hope this was the brief summary of all the closure properties that we wanted to discuss. And if you have this summary in your mind, most of the questions that we have in GATE, they can be easily solved. Almost all the questions can be easily solved. So let's see a few of the questions where we left. We did one question on closure properties yesterday. Let us do 3-4 more questions, so that will give us a confidence to attempt such questions in GATE, right? So let's see. So maybe I'll just pause the screen for a second so that you can take a snapshot or you can note it down later. So yeah, for closure properties, I'll just count on the count of 3. I'll change the slide. 1, 2, 3. And on this slide, we'll also stop for 3 seconds. 1, 2, 3. and on this slide also for 3 seconds. 1, 2 and 3. Yeah. So let's see the first question for today. Here is the question, and I'll again give you 2 minutes to solve the question. Let me set the timer. So it's an MCQ question and you have some 2 minutes to solve this. Yeah. So yeah. So mute everything. Okay. Yeah. Thanks. Yes. So yeah. So Kundan, it's an MCQ based question. You cannot have BC both. Yes. Good evening, Aman. So just try once. It has to be only one answer. I'll just give you 10 more seconds to think about it. Yes, Kundan, could you come up with the answer? Okay, so now I'll explain. I think we have waited for enough time for this question. Let's see what is the answer. So Hemashri says B. Yes, good Hemashri. Kundan also says B now. Very good, very good. So I think we have some 4 correct answers. Ankit, Abhilash and Hemashri and Kundan. They all are on the same page. So answer is B only. Very good, guys. So let's see how it is B. So okay. So as we say, L1 is a recursive language and L2 be a recursive enumerable language but not recursive, right? It is recursive enumerable but it is not recursive. So that is, it is a recursive enumerable language, right? So which of the following statements is not necessarily true? We have to answer this. Now you see L2 union L1. So I'll start from the from option D. Let's see how the options go. So L2 union L1 is recursively enumerable. It is being asked. Now you know that L2 is recursive enumerable. L1 is recursive enumerable. So recursive enumerable. Just a second. Just are not working. Let me check with the eraser. Okay. Right. So I'll go back to pen. Right. So this is recursive and this is recursive enumerable. Now you know by the Chomsky hierarchy that every recursive language is also recursive enumerable, and recursive enumerable languages, they are closed under complement under the union operation we just discussed. Therefore the language that we get is again recursive enumerable. So again guys, while doing this operation, that applying the Chomsky hierarchy, always try to go only one step above. Don't go multiple steps above at the same time. Okay? Right? Is it okay guys? So for example, when you are regular and something is you want something about if you want to go up in the hierarchy, if the so only go to the context-free languages. Do not directly jump on the recursive enumerable languages, right? I understand that every regular language is a recursive enumerable language also, but you have to jump one step above, right? Don't jump multiple steps, right? So here we say L2 intersection L1, whether that is recursive enumerable or not. Let's see. L2. What is L2? L2 and L1. So L2 is basically a recursive enumerable language, and my L1 is a recursive language. Okay? So is it okay? L2 is recursive enumerable and L1 is recursive. So we have to tell that it is not necessarily true. We have to check that. So this is recursive enumerable and this is recursive, right? So again, as we know, every recursive language is a recursive enumerable language too, and recursive enumerable languages, they are closed under intersection 2. We will get a recursive enumerable language again. So they are only not closed under set difference and complement. So therefore option C is, this is correct, but the option says it is not necessarily true. Therefore both of them are incorrect, right? So then we come to L1 minus L2. Now, as we discussed yesterday, L1 minus L2 can be written as L1 now ignite and L2 bar, right? We discussed yesterday. In the yesterday's example, we used the substitution. Yeah. Thanks, Nikhil. Yeah. So let's go back. So L1 minus L2 becomes L1 intersection L2 bar. Now L2, as I know, is a recursive enumerable language. Recursive enumerable languages, they are not closed under complement. We will get an undecidable language, right? So therefore it cannot be recursive enumerable. Therefore this option is false, and a question asked about the false option. So therefore answer is B, right? Since it is an MCQ, we can stop here itself, but again for the sake of completion, I'll complete this. For L2 minus L1, again, for L2 minus L1, I will write it as L2 intersection L1 bar. So L2 minus L1 is L2 intersection L1 bar, right? Now I know that L1 is a recursive language. L1 is a recursive language, and recursive languages, they are closed under complementation. So again, L1 bar is also a recursive language. L1 bar is also a recursive language, and every recursive language is also a recursive enumerable language. Therefore, this is about the intersection of two recursive enumerable languages, which is again closed. Therefore, this is also This is also true, and therefore it cannot be the answer. It is asking which are the false options, right? I hope the solution is clear to everyone, right? The answer is B, right? Okay, guys, should I move ahead? Everything fine till this? Okay. So let's move to the next question. The answer was B, right? So here is the next question for you guys, and I'll again give you 2 minutes to solve this. Yeah.
By you will have additional shear force. Now, my dear students, there can be a question asked, sir, how you can avoid torsion? My dear students, torsion, some part will be taken care by the shear. If the torsion is high, then we provide closely bars. We will reduce the spacing. That is the best way to avoid the torsion. My dear students, if you ask me what exactly is the difference between movement and torsion, torsion, when you do cranking, when you are doing cycling, when you are doing cycling, that crank wheel is nothing but torsion. A torsion is which is occurring along a radial direction. Movement is occurring in a plane perpendicular, means force into perpendicular distance in a plane. We talk about movement. When it is in a radial motion, or when you talk in polar coordinates, then we talk about the torsion. What is the point I would like to understand from you, my dear students, is equivalent shear is given by the formula shear force plus 1.6 Tu by B. When the shear force is more, then you will design more steel for secondary reinforcement. And remember how much it has been added is 1.6 Tu upon B. I hope you are clear. Is it clear, my dear students? Quickly answer me. Now, please see this question, my dear. This is a simple question. I want everyone to look at this question and try to understand. First, read the question, my dear students. A singly reinforced beam section is shown in the figure. Okay, is shown in the figure, not drawn to the scale. Okay, that's leave about that point. Is made up of M25 concrete and Fe 500. The Fe is 2 mm.
So yes, guys, what are the answers? Gagan says AC, Avilash says ABC. Let's see. So you guys are not conquering. Just cross check once. Kundan also says ABC. Gagan, cross check. Two guys are saying ABC. Hemashri also says ABC. Good. Yes. So answer is ABC. Saurav, you are also correct. Let's see the solution now. So I'll stop the clock. Okay. So let L1 is regular language. So it's already given that L1 is regular. L2 is a context-free language. L3 is a recursive language, and L4 is a recursively enumerable language. It's already given in the questions. We have 4 languages, and almost we have covered all the classes, right? So now, which of the following is or are true, right? So now, again, so it's very important. Please read the question carefully. Sometimes students mark the questions wrongly. They do not read that they are asking for false, right? So just it's also very important with the presence of mind that just read the question carefully, right? Okay. So which of the following is or are true? So when we say this, let's see, L3 bar union L4. So this is complement. I hope all of you understood this. So complement is represented in various ways. Either we can represent complement by a bar, or we can represent it by a dash or negation operation. So all these are complements only, right? So L3 bar union L4 is recursively enumerable. Let's check that. What is L3? What is L3? L3 is a recursive language. L3 bar, we know that they are closed under complement, so the L3 bar is also recursive. Now L4 is recursive enumerable, right? Now there is a union. Now every recursive language, as I said, will go one class above. It is recursive enumerable. Now recursive enumerable union recursive enumerable is again recursive enumerable. So therefore option A is correct. So option A is in the answer, right? Gagan, could you find out B is okay? Just cross check. So let's check B together. L2 union L3 is recursive. Now L2 is context free, and every L2 free, and L3 is recursive. It's already given. L2 is context free language and L3 is a recursive language, right? And the union has been asked. L2 is context free and L3 is recursive, right? So now we know that every context free language is a recursive language, and recursive languages, they are closed under union. So therefore this option is also correct, right? L2 union L3 is recursive. This is also correct. Above language is already low level language. Okay. So Gagan, yes, we are going 2 levels above. Yeah. So first you will go 1 level above. If you do not have an idea, then you can go 2 levels above. You will not directly jump. You're right, Gagan, in this point, right? Right. So next we go to the last option. Next option, L1 star union L2. So what is L1 star? L1 is a regular language. The regular languages, they are closed under clean closure. So therefore this entirely, so this is for L1. So this is for L1, and L1 star is also regular, right? So L1 star is also regular. Now union with L2. What is L2? What is L2? L2 is a context free language. Context free language. Now we know every regular language is also a context free language. Context free languages, they are closed under union. So therefore we get a context free language. So therefore C is also correct, right? Yes. And then we have next thing as L1 union L2 bar. So what is L1 union L2 bar? So L1 is a regular language union L2 bar. L2 is a context free language and L2 bar. So L2 is a context free language. L2 is a context free language, and L2 bar, the complement of it, which is not closed, it is not a context free language. Therefore once we union it, we cannot get a context free. Therefore this option is incorrect. So the answer is A, B and C, right? I hope everyone got it. Kundan says above language is already low level language. What do you mean by low level language, Kundan? I'm not very clear. Can you elaborate on that? So meanwhile we'll move to the next question. Let's see. So again, this is the simplest question that can come on the closure properties. Let's see. I hope everyone should be able to answer this within a minute. It's a very, very simple question.
formula, three stages.
Hmm. So Kundan says 4, Hemashri says 5. So again Gagan says 4. Again, I think guys, please concur on one answer. I'll wait for 30 more seconds. Abhilash also says 4. Okay. Okay, Gagan has come back to 4. What about Hemashri? What do you think? You can just refer to the table that I just drew, and in general, yeah. So okay, so I'll answer this question now. It's already 1 hour 46, 1 minute 40 seconds. Himashi, just can you cross check your answer? Okay. Okay. So again, I'll solve now. It's already 2 minutes. Okay. So which of the following languages are closed under complementation? Again, why I purposefully kept this question because complementation in general is the most important property, and many a times the question has come around 10 to 15 times the question has come on complementation. So therefore I purposefully kept this question so that you all remember this property like properly, right? And always remember complementation is not closed under only two languages, which is recursive enumerable and context free. At all other places complementation is yeah, at all other places complementation is closed. So therefore the answer is 4, right? Yes. Yeah. Is it okay, guys? Should we move ahead? Yeah. So Himashri, could you comment like which of the ones you missed? You counted 5, which is the extra one which you counted. Maybe meanwhile, and the meanwhile I'll move to the next question. So always remember about complementation. It's a very, very, very important property, right? So now let's move to the next question, which is again a very, very simple question. I have kept it purposefully because to highlight something, I'll highlight at the end. Maybe first of all, you guys solve this question. And this should not take more than a minute. Yes, Gagan, you are right. AD is the answer. AD is the answer. Kundan, you are also correct. Abhilash, you are also correct. So again, it was a very, very straightforward question. Again, why I gave this question is to make you guys realize again. So in properties, if we ask, complementation is one of the most important properties, and in languages, if we ask, the context-free languages are the most important languages, and many a times a question has come on context-free languages and the property, the complementation property, right? And you all know that the context-free languages, they are not closed under only two of the operations, three of the operations, that is intersection, set difference, and complement. So therefore these two options are correct, and we get A and D as our answer. So by this we move to our last question for closure properties. Let's see the last question on closure properties, and then we will start with the DFAs and the finite automata, right? So let's see the last question on closure properties. Yeah. So here again you will realize the importance of context-free languages. That is why I purposefully kept the last question. So again, I'll give you again 2 minutes to solve this question. Yes, Hemashri, it was AD. Yeah, good. So Gagan, you are incorrect. Cross check once again. So it's again an MSQ based question. So just remember that's an MSQ based question. Just check out all the options. Yes. So yes, guys. So all of you are correct. Kundan, Abhilash, and Gaganjit. The answer is AC. So Hemashri, no, the answer is AC. Just cross check once. And C is also there. Good, Hemashri. So let's see. Let L1 and L2 be any context-free language. So we have a context-free language. L1 and L2 are both context-free. And then we also have R, which is a regular language. So now let's see what are the options. So the first option says L1 union L2 is context-free. So L1 union L2 is context-free. It is asking this. Again, the context-free languages are closed under union. So therefore A is the answer. A is the correct option. Now L1 complement is context-free. L1 is a context-free languages. They are not closed under complement. So therefore B cannot be the answer. Now L1 minus R is a context-free language. So this is the next option. So what is L1 minus R? So L1 is a context-free language. R is a regular language. And minus, as we wrote earlier, set difference can be written as L1 intersection R bar, right? Now, regular languages, they are closed under complement. So therefore this again becomes CFL's intersection with a regular language, which is again closed. Therefore it is a CFL. We know that CFLs are only not closed under intersection, set difference, and complement. So therefore we can say that L1 minus R is a context-free language. C is also correct. Last is L1 intersection L2. We just saw that they are not closed under complements, under intersections. This is a CFL. This is also a CFL. So the language that we get is not closed. Therefore, the answer is A and C. So I hope you guys got a flavor of what are the kind of questions that can come over in when we talk about closure properties, right? So Saurabh, yeah, A and D was incorrect. AC is the correct answer, right? Okay, so I hope this clears all your things about closure properties. And then just remember the table that I just drew. Almost 99% questions you will be able to answer, and you should be confident about the solutions, right? So now let's move to the next topic, which is finite automata. So again, we have already covered, as I discussed, the three most important topics, and we expect 2 to 3 questions from these 3 important topics: decidability, closure properties, and identification of the type of the language. Now we are moving to the other important topics. The first one is finite automata. Let's see certain questions on that. So it's a NAT based question, and I'll give you some 2 minutes to solve this, but I hope you will be able to do it within 1 minute. If you guys do it in 1 minute, I'll explain the solution there itself. Yeah. So Hemashri says, but set difference is not in CFL is not closed. Yes. So again, in that option, if you directly move above, it becomes a problem. So initially, so this is make it a point that first of all, you will try to do something while remaining in the class itself. When you move up, you will only move up when it is exactly needed, right? All right. So Kundan, no, your answer is incorrect for this question. Himashi, you got my point? You'll only go up when it is absolutely needed. Otherwise, you will not go up. Gagan, wrong. Your answer is incorrect. I knew all of you will do the same mistake. That's why I purposefully kept this question. Just read the question carefully. You'll understand the trick behind it. Yes, yes. I think Kundan got the idea. Just cross check. Yeah, Gagan also got the idea. Good, good. Just cross check. So I purposefully kept it like this. Oh, Kundan reached to 4 states. No, no. It's wrong, incorrect. Hemashri, you are right. Gagan, you are right. Kundan, just cross check your answer. What about Abhilash? Where do you stand? What about Saurav also? Saurav also came to the right answer, right? Abhilash, I'm just waiting for your answer. 10 more seconds and then I'll explain it. Yes, good. So I hope all of you got the trick also. Kundan, can you specify the question in detail? Clean closure is there? Like I'm not very clear about the context. What do you want to ask? Maybe write the full sentence so that I get to know what do you exactly want to ask. But let's see this question first. Meanwhile. So the number of states in the minimal finite automata which accepts set of all strings over sigma equals to AB such that the string starts with an A. So now the keyword over here was finite automata, minimal finite automata. And all of you, when you answered it, you ended up making DFAs for this. Nobody said that you have to make a DFA. Okay, so again, Kundan, when we say that the language over sigma equals to AB, it means A plus B star itself, right? The complete language. From A plus B star, I have put up the condition that its strings should start with an A. So when we say, if you read this sentence, it says, which accepts set of all strings over sigma equals to AB. So all strings over sigma equals to A plus B star, which is the mother of all languages, the universal language. Out of that, you have to only accept the strings which are starting with an A, right? You got the idea? Yeah? Yeah, yes, good Kundan. Yeah, exactly. So for a finite automata, the answer is 2. For DFA, the answer is 3. You all of you are correct, right? So when nothing is written, you have to you should make NFA, because in general NFA will have lesser number of states than a DFA, right? When it is if the question specifically says minimal deterministic finite automata, only in that case you are going to draw the deterministic finite state automata. Otherwise, go with the NFA. Is it okay, guys? I hope till this point everyone is on the same page, right? Right. So let's move further. Again, so let me draw this also. So when we draw the NFA for the same, yes, the NFA for this will be something of the type. The answer is 2. So let me briefly summarize DFA also, so that so that everyone is on the same page and you are also able to solve the questions which are going to come further, and we will do some 4 to 5 more questions on DFAs. So I'm just summarizing DFAs for those who are new, and for those who do not know the concepts properly, and just for brushing up for those who already know. So I'll just take 5 minutes to summarize the things, and meanwhile together I'll solve the solution. I'll give the solution for this question also. See about NFAs. So when we draw an NFA for the string starting with an A, so the NFA will look like this. This is the final state and this is the initial state, right? So this is the NFA for string starting with an A, and we get 2 states in this NFA. 2 states in this NFA, right? And when I draw the DFA for the same, yes, when I draw the DFA for the same, it will look like A comma B and B A comma B. Sorry, this should not be final state, this is a dead state. So right, is it okay guys? So this is how we make the DFA for this. So the DFA will have 3 states. The DFA will have 3 states for the same question, right? And so how do we define NFAs and DFAs? So when we say for the DFA, we have a 5 tuple which goes like Q, sigma, delta, Q naught and F, right? I'm just giving the brief theory within 1 or 2 minutes so that you are able to solve all the questions properly. And for NFA also the tuple remains the same. The only difference is what guys? So I think, can someone comment what is the only difference when we say about NFA and DFA in this tuple? So Q remains, Q is basically the set of states. The set of states, sigma is your alphabet, delta is your transition function, Q naught is your initial state, and F is your final state. Set of final states. So there can be more than one final state. So what is the only difference? Yes, Gagan, you are correct. The transition function is different. The delta is different. Abhilash, you are also correct. So when we say delta, so what is delta what is the delta for DFAs? The delta for DFAs is Q cross sigma goes to Q, and delta for NFAs is Q cross sigma goes to 2 raised to power Q. That's the only difference. So when we say deterministic, it is deterministic finite state automata, and the transitions are deterministic. That is, on a single Q and on a single sigma, you are only going to one state. You cannot go on multiple state, and for every Q cross sigma, you have to write the transition, right? And similarly for NFA, the thing changes. For every Q cross sigma, you can have multiple transitions, you can go to multiple states, or you may also not go to any state. So for example, in this NFA, when you see on B, on state Q1, there is no transition. Okay, so this is an NFA on B, and in this, if we see, we have the Q1 has transitions over A comma B, Q2 has transitions over A comma B, and Q3 will also have transitions over A comma B. So this is a DFA, right? Till this, everything is clear? Choice, epsilon, remove, and dead configuration, state cross sigma, union epsilon, 2 raised to power Q, state cross sigma, union epsilon. Again, Kundan, when you say state cross sigma, union epsilon, that becomes an epsilon NFA. I just talked about NFA. In epsilon NFA, you are correct. Instead of sigma, we will have sigma union epsilon, right, Kundan? You got the point? So, in epsilon NFA, what you are saying is correct. I only talked about NFA, non-deterministic finite state automata, right? So, I think till this point, everything is clear. And now, let's see what is the conversion procedure. I hope all of you know that, but just for quick revision, I'll just also tell you how to convert an NFA to a DFA. Let's take this example itself and then see whether we are able to get the same DFA or not, right? Let's see. So the DFA that we have is, the NFA that we have is, just a second, do we have a blank page? Yes. So the NFA which we drew earlier was Q0, and we were going to Q1 on A, B and A. So now how do you guys convert it? You first of all, what is the first step? The subset construction is the method. Kundan, you are correct. You are perfectly correct. So maybe you guys can also keep on drawing parallelly. So for Q0, so first of all you will draw the transition table for the NFA, which says on Q0 on A goes to Q1, Q0 on B goes to goes nowhere, which is phi. Q1 on A goes to Q1 and Q1 on B also goes to Q1. So this is the transition table for the NFA. Now if I want to convert from NFA to DFA, I'll start from the transition table, remove unreachable states. Yes, I think the unreachable states needs to be removed first, but there is no state unreachable over here. The first step is to take the transition table and also remove the unreachable states. Right, Kundan? You are correct when you are saying this. Now the next step is you will draw the transition table for the DFA and you will take the help of the transition table of NFA. You will start from the initial state of the NFA. What is the initial state for NFA? Q0. You will start from Q0, the initial state remains the same, and you will keep on writing the transitions. So Q0 on A goes to Q1 and Q0 on B goes to phi. There is nothing called phi in DFA. What we have is a dead state, right? So Q0 on B will go to a dead state. I will call it as QD. And what do we know about the dead state? Dead state on A will also go to QD, and dead state on B will also go to QD, right? So can someone tell me what is a dead state? What is a dead state? So this directly we can add trap state, it will become DFA. Yes, exactly, Kundan. So what is a dead state? What is a trap state? So from where? So can somebody define the trap state? Meanwhile, I'll solve the question. So Q0, and we will also write the transition for Q1. For Q1 on A goes to Q1 on A goes to Q1, and on also in B also it goes to Q1. So this is basically the DFA for the same language. We have converted an NFA to DFA, and we should know this, that every NFA can be converted to an equivalent DFA using the subset construction method, and the maximum number of states that we can get is 2 raised to power n. Okay, so right, state from which initial cannot be reached. No, Gagan, it should be state from which final state cannot be reached, right? So it's a dead state. We cannot reach the final state from that state. That state is called a trap state. Indirectly we can add, yeah, correct. So now this was a simple example, but for the completion of the concept, so for example, it might happen that Q0 in NFA goes to, or Q0 on A goes to say Q1 comma Q2. It might be the case. So this question is complete. I'm just completing the theory for subset construction in Vermont with it. So delta on Q0 comma A, let's say it goes to Q1 comma Q2. The delta dash if we define for DFA, so this is NFA and this is DFA, what we will get is Q1 Q2, this will be just one state. So Q1 Q2, when I'm writing it down, this is one state and these are two states, right? So this is the procedure which we use. That is one thing that you have to remember. So this is how you are going to do. And for calculating the transitions of these combined states Q1 Q2, you will use the union of the transitions of the DFA, of the NFA, right? So in general, yes, Hemashri, you are correct. It cannot reach the final state. Perfectly fine, right? Yeah. So now what is basically the transition function? For example, if I want to find out delta dash of Q1 Q2, delta dash is my transition function for the DFA and delta is my transition function for NFA. So now delta dash of Q1, Q2 on A, what will be that? Can someone comment? What is delta dash of Q1, Q2 on A? How do we calculate this? How do we calculate this? So it will be, I'll write it out and then I'll check your answer too. So it will be delta of Q1 comma A union delta of Q2 comma A, right? And this is how you are going to do for all of them, right? So delta of Q1A and delta union delta of Q2A. You are perfectly right, Abhilash, in this. And then, yes, Gagan, you are also right, right? And you have to do it this procedure for all the states. And mind it that you are only going to do this operation for the states which are reachable. For unreachable states, you are not going to do this, right? So I think this is all about subset construction, and any example if it comes of conversion of NFA to DFA, you can solve it, right? Now let's see the next question. And the maximum number of states, I said that the maximum number of states that you can get is 2 raised to power n. It cannot be more than this, because if there are some n states in an NFA, what are all the subsets that you can make? That is 2 raised to power n. So that is why we say 2 raised to power n can be the maximum number of states in DFA. Again, an important point, what are the final states? All the states which have any of the final states of NFA will be the final states in the DFA, right? So for example, in this case, Q1 was the final state, so Q1 will also be the final state over here. So this completes the theory for NFAs, DFAs, and a brief summary of all the two types of finite automata, that is NFA and DFA, right? Now let's see the next question. So again, it's a very simple question, but I'll give you 2 minutes to solve this. So okay guys, I think Abhilash, you are correct. Hemashri, you are also correct. Saurabh, you were wrong earlier. Now you are correct, and Kundan is also correct. Yeah, all of you answered it correctly. Gagan, you have also answered it correctly. All 5 of you are correct. So the answer is P, C, D. And I hope. So again, so when I say that about the language, about the first language, yeah. So about the which of the following languages are regular? So again, when we see this, when we have to compare the number of A's with number of B's, we require the functionality of a context-free language. It cannot be a regular language, right? You cannot do this with the help of a what do we say is a context-free language, with the help of a regular language. Over here, you are comparing the mode of NA mod with NB mod 3. So the modulus operation allows you to limit the number of states. Therefore, this is a regular language. Again, even if you use one modulus operation, the other part is infinite. Even then, you can limit the number of states, and you do not require the functionality of the stack, and therefore these two are also regular. So the answer is B, C, and D, right? So yes. So now I am expanding these three things again in the questions that are going to come. I am asking you to make DFAs for all of them, and then let's see whether you can also draw the DFAs for all of them. Since they are regular, you will be able to draw DFAs for all of them, right? So let's see the next question. B, C, D is the answer. So here is the question for you guys. I'll give you again 2 minutes to solve this. It's a NAT based question.
Krishna, why it is less than or equal to? Why is it not just less than? Okay, Ramakrishna, that's a good question, Amma. What I would like to tell you is, this DF is known as depth of flange, Amma. This DF is known as depth of the flange. When the depth of neutral axis is less than, means what is less than indicates that when the neutral axis is less than, when the depth of the neutral axis is less than depth of the flange, means it will be inside the flange. The neutral axis lies inside the flange. Now, if it is equal to the depth of the flange, the neutral axis will somewhere lie here. Means it will lie at the edge of the, then also it behaves as a rectangular beam. Whether it lies on the interface or inside, both will act as what, my dear students? In both the cases, it acts as a rectangular beam. So, my dear students, that is a good question, Ramakrishna. So, no need to worry that when XU is less than or equal to, you should understand that the beam behaves as a rectangular beam. The beam behaves as a rectangular beam. So here, my dear students, what is the important thing I would like to tell you here is the next case. Ramakrishna, I think you are following. Okay. Now, the second case is, what is the second case here we have is the case 2. Krishna, as you told, XU is less than or equal to DF, the neutral axis is going flange. Now, suppose if XU is greater than DF,
Guys, Abhilash says 3 final. Yeah, so Abhilash, you are correct. 66.67, and Hemashri says 67. So Hemashri, you have to round up the answer to 2 decimal places. And Kundan says it will become grid machine. Yes, Kundan, but what is the answer? Okay. Himashi, you are correct now. Kundan, what is your answer? Yes, Kundan, you are also correct now. So let us discuss how it is the answer. I'll discuss. So the answer is 66.67%, and there are three final states, and nine known. Six, three, and then we have nine total states, six non-final states. So the answer is 6 by 9, which is 2 by 3, which is 66.67. Right? So I hope all of you got it correctly. And how to approach these kind of questions, the modulus questions, again, as Kundan rightly pointed out, we can make a grid for these questions, and but for solving this question particularly, you don't need the yes, Kundan, you're correct. I'll also make the machine for you. You can cross check from that, but in general, you do not need to make the machine for such kind of questions, because you can just simply do the calculations. For example, we know number of W's in B, A mod 3 can only take three values 0, 1 and 2. Number of B's in W mod 3 can take three values 0, 1 and 2. So in total we'll get 9 states, 3C1 into 3C1. So total we get 9 states. Now let us try to find out how many states are final. So now when I say let us fix the B to 0, and I said the question says, what is the question? The question says number of A's mod 3 is greater than number of B's mod 3. So number of A's have to be greater. Now when B is 0, number of A's mod 3 can be 1 or 2. Number of A's mod 3 can be 1 and 2. Now when your number of B's mod 3 is 1, then it can only be 2. When it is 2, number of A's mod 3 cannot take any value. So therefore we get 3 final states. That means 6 are non-final. You can simply answer it as 6 by 9 into 100, which is 2 by 3 into 100, right? So I hope this clears the calculations for this question. And of course, you can also draw the DFA. How does the DFA looks like? It's like a web DFA. Let's see how the DFA exactly looks like, right? So let's see the construction of the DFA also for a while, because this will help you. Why I'm making the DFA right now? Because this will help you in solving the next question which I'm going to ask. So let's see the DFA for a while. So what we do is, in general, what we do is we vary the number of A's or number of B's horizontally. So one part we will number of A's will move horizontally and number of B's will move vertically, or we can do the other way around also, right? So what I am doing is I am taking B's horizontally, number of B's horizontally, NB mod 3. This is the for checking the number of B's. I'll make one more for B's like this, and similarly like this one more time, because I want 9 states. This is also B. Now A's will move vertically like this. A's will move vertically like this. So quickly you can make up the DFA also, but again for this question particularly you don't need to draw the DFA. You can simply answer it with the help of the calculations that we did, like the permutations and combinations, right? So over here, if you want to see the final states, so here we have 0. So this is in this column the A's are constant, the A's are 0. The number of A's mod 3 is 0. It will be 0, 0, 0, 1, 0, 2. Here the number of A's are 1, that is 1, 0, 1, 1 and 1, 2. Here we have the number of A's are 2, so that is 2, 0, 2, 1 and 2, 2. And if I see this, I can clearly say which are my final states, where number of A's mod 3 is greater than number of B's. So this is the final state, and this is the final state, and this is the final state. So this is actually which is going on behind when we do the calculations, right? I hope everything is clear. Kundan, you made the same machine. Is there any difference? Can you cross check? Yes, very good, Kundan. So now let's see the next question. And for that question, you have to draw the DFA. If somebody can make it without the DFA, we'll see if somebody can do that. But let's see. So this is the question, and I'll give you another. So I think this is a bit tough question. I'll give you 3 minutes to solve it. Yes, Gagan, you're right. Just the percentage is not correct. Rest all is fine. You have to round it off to 2 decimal places. I forgot to mention. I'll mention it in the question. But otherwise, you are perfectly correct. Let me write it down. Round off to 2 decimals.
This distance is what, sir?
We only have the answer from Gagan. What about others? It's 47.62. Yeah. You ended up while doing rounding off, you ended up with the before decimal point is not changed, right? Yeah, Kundan, just do it, no issues. Okay, okay. So yes, Kundan, you are on the right path. Just last 30 seconds for this question, then I'll solve it. Sorry. So yeah, is it audible now, Kundan? I've unmuted it. Yeah. Okay. Yeah, just can you, Kundan, can you confirm? Is it audible now? Okay. So, 47.62 is the answer, and let's see how do we get this answer, right? So, so the question was, let me see the question once again. NAW mod 5 is greater than NBW. NAW mod 5, NAW mod 5 is greater than NBW, right? Now let's see the possibilities first. From there we'll get an idea that how to draw the DFA, right? Okay, so for NB, the possible combinations are, let's see with the respect to NB, what are the possibilities for NAW mod 5. So NB, and this is NAW mod 5. So let me write the possibilities here. I'll draw the DFA side by side. So for NB, the possibilities are, if the number of B's are 0, number of A's mod 3 has to be greater than this. There is no possibility for NAW mod 5 for a final state. Is it okay, guys? So it has to be, if NB is 0, NAW mod 5 has to be greater than this. Okay, so there are various possibilities. Sorry for that. Eraser. So what are the possibilities for this? So your NAW mod 5 can be 1, 2, 3 or 4. It cannot be 0. So we have 4 final states from here. Is it okay, guys? We have 4 final states from here. Are you getting this point? Right? And then for NB, if your NB is 1, number of B's that are there in the string are 1. So what are the possibilities for NAW mod 5? It can be 2, 3 or 4. So thereby we get 3 more final states from here. So this makes the count of the final states as 7. Right? Now if I make the NB as 2, the number of final states that I get is 3 and 4 over here. So I get 2 final states from here, and continuing the same for 3, the only possibility is 4. Therefore we get a 1 final state from here. So as soon as NB touches 4, there is no possibility that NAW mod 5 is greater than NB. Therefore we do not get any final state over here, which is 0. If we sum it up, we get 10 final states. Kundan, do you get that? Why we have 10 states? We do not require 11 final states here, right? Is it Kundan? Yeah. So we have a total of 10 final states in this DFA. And now let's try to draw the DFA. So this gives you the idea of final states, that there are going to be the 10 final states, but this does not give you the idea of all the states that are going to be there in the DFA. Let's see how many total states are there in the DFA, and let's try to find out. Right? So over here, I will again do the same. I will draw B's, A's vertically or A's horizontally, and I will move B vertically. How many rows I want? Okay, let's see. 1, 2, 3 are here. I will require more space. Let's see how do we settle this. So how many states that we require? I think let's see what we have drew till now. So let's see. We will cross check whether we need another level or not. Let's see. Where is there is. Yeah. So let's see that. Yes. So let's see what is happening. We'll calculate. We'll see what is happening at each state. So if we see, vertically we are going to move B. Vertically we are going to move B, right? So now if you move the B vertically, over here in this line, if you see, number of B's are 0, A's are increasing, and that by virtue of that, we can say that this, and this is going to be your final state, because number of B's are 0, but number of A's are increasing. That is 1, 0, 2, 0, and then we have 3, 0, and 4, 0. And we saw 1, 0, 2, 0, 3, 0, 4, 0 are all final states. Is it okay? Right? Now, if we see this line over here, the number of B's are 1 over here, and when number of B's are here 1, but we can say 2, 3, and 4 are going to be my final state. In this row, number of B's are 2 now. Number of B's are 2 now, and when number of B's are 2, then the final states that you get are only 3, 4, 2 states are final, which is 3, 4. And when number of B's are 5, number of B's are 1, 2, 3, 3 B's are there, then only one state is final, which is 4, 0, 1, 2, 3, 4. This is the final state. Now you see, when I increase the number of B's to 4, there is no final state. Therefore, I do not need to make any other grid now. What I can do is I can make one state, and all of the B's can come here. All of the B's can come over here itself. And after that, whatever you get, either A or B, you are not going to get anything final, because the number of B's have crossed 4. NA mod 5 will never be able to cross this. So total there are 21 states, 5 4 are 20 plus 1 21, and out of that 10 were final. So we get 47.62 as the percentage. So 47.62 is the final answer. Is it okay? Yeah. No, this is not the final state, Kundan. This is not the final state. This is a dead state. It's a trap state. It's a trap state. This is not final. This is a trap state. Because now number of bees are greater than equal to 4. In this state, number of bees are going to be greater than equal to 4. You cannot have Na mod 5 greater than 4. Right? Okay. Right. So you took it as final state, therefore you got the wrong answer, but otherwise your approach was perfectly fine. Right? So guys, let's see the same question. It is also on the similar lines, but I hope this time you will be able to solve within 3 minutes. Last time you took 5 minutes to solve this. This time you should take less than 3 minutes. Let's see the next question. Is it okay till this? Everyone is clear? Everybody? Hemashri, you could not get the answer. Are you okay with the solution? Kundan got it. What about Hemashri? Abhilash, you also could not got the answer. Oh, Kundan says crystal clear. Good. Okay. Right. Abhilash also got the right answer. Perfectly fine. Gagan, you got it correct in the first go itself. Good. So what about who was the other one? Saurav, what is your status? Are you getting it? Okay. So let's see the next question. So again, I'll give you some 2 minutes, 3 minutes. Yes, good, sir. Yeah. It's not 42.24. Can you write your fraction so that I get to know where you are going wrong? So again, so Kundan, so Gagan, it's fine. The fraction is fine. I think you did a calculation mistake. Just cross check. The fraction is perfectly fine. So Gagan, as I said, fraction is fine. Just cross check the percentage calculation. I think you have made some mistake over there. The fraction is right. So okay. I think almost all of you have reached the correct answer. I don't know why you are doing small calculation mistakes. I hope the fractions that you have got are correct. Again, round off to 2 decimal places. I forgot to mention. Just cross check your answers. So rounding off, I don't know why you are making mistakes in rounding off. Round off to 2 decimal places. Minor mistake in there in the answers, but otherwise you are correct. All of you are correct. Yes, Gagan. Again, rounding off. It comes out to be. It comes out to be 42.307, right? 42.307, and if I round it off, it becomes 42.31, right? Right. So Kundan, Abhilash, right? Yeah. Good, good. So rounding off is a bit of a trouble. I think rest everything is fine, perfectly fine. Yeah. So now, in general, they'll keep the range from 42.30 to the 40.2.32. But if they keep it perfectly rounded up, then you might be in trouble, right? So better to follow the instructions properly, right? Okay. So let's see. So 42.31 is the answer. Now let's see the answer now. Okay, everybody could find out. It is 42.31, right? So now let's see the possibilities for this. So what was the question? It was NAW more greater than NBW mod 5. Let's see. So NAW greater than NBW mod 5. So NAW greater than NBW mod 5. So let's see the possibilities in this example. So over here for NBW mod 5. So again, I'll keep NAW over here and see what are the possibilities for NBW mod 5 to find out the final states, and then I'll see if I can reduce further. So now when NAW is 0, number of A's are 0, in no way it can be greater than NBW mod 5. So in no way it can be greater than NBW mod 5. We do not have any final state in this case. When NAW is 1, NAW is 1, then NBW mod 5. So it can be greater than, NAW is greater than when NBW mod 5 is 0. There is one possibility, right? Kundan, can we do it in 25 states? Let's see, Kundan. I think we can do it in 26. Let's see if we can make it 25. Let's see. Maybe you can suggest once I draw what can be reduced, right? So next is when we have NAW as 2, so it can be 0 or 1. We get 3 final states till now. For 3, it is either 0, 1 or 2. For 4, when NAW is 4, NBW, if it has to be greater than NBW mod 5, so NBW mod 5 can take the values 0, 1, 2 and 3, right? So till this is 4 plus 3, 7 plus 2, 9 plus 1, 10 states. The last one is when it is greater than equal to 5. So when it is greater than equals to 5, all the possibilities are satisfied. 0, 1, 2, 3 and 4, right? When it is greater than equals to 5, it seems that we might end up having 4 plus 3 plus 4 plus 3 5 plus 4 plus 3 plus 2 plus 1, these many number of states, right? But let's draw the automata and see, do we actually get these number of states, right? Is it okay till this point? Is it okay? This calculation is okay. This we need to check whether some merging business can be done or not, but otherwise this is how the DFA will look like. Okay, the calculations will be somewhat like this, and let's see whether we can do some merging or not, right? So again, these calculations, whenever you do these calculations, always try to make the DFA, because the minimization can always be done, and you will have to draw the DFA to see whether you can minimize certain, whether you can merge certain states or not. Okay, so always look for minimization whenever you draw the DFA, and always look at the meaning of each state, right? Otherwise you might end up drawing more number of states, right? Okay, so let's see how the DFA looks like for this example. So over here, what I'll do is, again, I will draw. Just a second, I'll require more space to draw this. I will erase this part. I'll write it smaller. Right. So now what I want is, number of bees I'll move across the rows, horizontally. And A's I'll move vertically. Okay, so you can do the other way around also. There is no issue. See the situation now, and then let's see whether we require another level or not. Let's see whether we require another level or not. So this is the situation of bees. Let's see whether we require a level or two. We will see. So let's see, on this row, number of bees are 0, right? Number of A's are 0. Over here, number of A's are 1. Right? So now when you say number of A's are 1, number of B's can be 0. So this state is final state. None of the states in the first row is final. Okay? In the second row, let me make this first, then we will discuss. So in the second row, number of A's are 2. For 2, 0 and 1 are the final states. third row 0, 1, 2 all are final, and for fourth row 0, 1, 2, 3 are final. Now when I go to the fifth state, when number of A's are 5, I see that after that the number of B's mod 3 mod 5 is not at all mattering. So why don't we merge it in one state and say this is my final state. When number of B's have crossed 5 or equal to 5, it is A, number of A's have crossed 5, then in that case this is A, and this is also A, and this is also A.
Okay.
In this case, this is not a trap state. Oh, your smile is too good and teaching style is also. Okay, thank you. So, is it okay? So, okay, so everybody could draw this, and now we see that this is one final state because we have merged all of them. This is 4, this is 2 plus 3 plus 2 plus 1. We get 4 plus 3, 7 plus 2, 9, 10 plus 1, 11. 11 final states. And what are the total number of states? 26. 11 by 26 into 100, which comes out to be 40. What was the number? I forgot. What was the number? 42.7. You can calculate that. Is it okay? Right? Yes, Kundan, 26 is required. Are you convinced now? Yes. Okay. So now let us see the next question that we have. Meanwhile, Kundan replies, and yes, Kundan says yes. It's fine. Let's move to the next question. Right. So here is the question for you guys, and yeah. So I think 30 seconds are enough for this question, but I'll give you 1 minute for this.
Repeated load.
Again, it's an NAT based question. So Himashri, how would you get 10 states? It's incorrect. Just cross check your answer. Yes, it's already 1 minute. It should be done within that time. What about others? Just cross check. Abhilash, you are correct. Yes, Himashri, you are correct now. What about others? Kagan, Kundan, and who else was there? Saurav, what are your answers? Good, Saurav, it is correct. Gagan, and we'll just wait for 10 more seconds for Kundan and Gagan to answer. Yes, Kundan, you are also correct. And Gagan, you are also correct. Perfectly fine. Everybody, all of you calculated it perfectly fine. And the answer is 5. I'll stop the clock. It simply says when interpreted. So it says what is the number of states in the minimal DFA. Again, here the keyword is DFA. Read the keywords carefully, which accepts set of all strings over sigma equals to 0, 1 such that the strings when interpreted as a binary number is divisible by 5. So what are, again, in this case, you do not need to make the DFA it's very simple. You can simply calculate it saying that what are the 4 possibilities that you have. Either when you divide something by 5, you get the reminders as 0, 1, 2, 3 and 4. So the number of states will be 5. And the state which represents 0 as the remainder will be your final state. If I ask you what is the percentage of states which are non-final, it will be 4 by 5, which is nothing but 80%. Right? So in these cases, you do not need to draw the DFA. You can simply answer it. Using your imagination for the remainders, right? You don't need to. You can do it without making the DFA itself, right? So I hope you got the point, right? All good. So now let's see the next question. It's a linked question to the same question. I hope you remember the question says this, that you have to draw the what is the minimal DFA which accepts set of all strings over sigma equals to 0, 1, which when interpreted as a binary number is divisible by 5, right? So Kundan, then my next question is based on that only. It's a linked question for this question. First of all, you guys try to draw the DFA, and then I will answer you how to draw the DFA, right? So this is the next question, which is a linked question to the same question. And the question says something like this. So it's a MSQ based question, and I'll give you some 2 minutes to solve this question. So here I have forced you guys to make the DFA. Without making the DFA, you cannot answer it, because I wanted specifically I wanted that you have to make the DFA, right? And then now you have to solve it after making the DFA only. Himashi, it's an MSQ based question, so just cross check your answer once.
Oh, discussing.
So Saurabh says AB, Himashri also says AB, Abhilash also says AB. Good, good. Kaushalya says B. Kaushalya, cross check your answer. Hemashri has also come back on AB. Yes, Gagan, you're right. There is a short trick for the same, and we discussed that in the class, right? You applied the short trick, Gagan, is it? Yes, Kundan, you are also correct. AB is the answer. So now let me explain. So again, when Kundan, you asked me that how to draw the DFA, the actual approach should have been, we know that there are some 5 states and you will end up making the DFA as. So the answer is AB, and you will end up making 5 states: Q0, Q1, Q2, Q3, Q4. And if you go like this, you know Q0 is your initial state and the final state itself, and you will write the transitions on 0 and 1. You will have to write the transitions for 0 and 1 for this state also, for 0 and 1 for this state also, for 0 and 1 for this state also, and 0 and 1 for this state also. And while how are you going to do this? You keep on taking the strings and then you check the remainder, right? So you keep on taking the strings and you keep on checking the remainders, right? So so for example, like you check whether for the string 0 0 what is the remainder, for 0 1 what is the remainder, 0 1 1 what is the remainder when divided by 5, and so on. This way you will be able to complete this entire DFA. But that approach will take a lot of time. We do have shorter trick for such type of questions. What you are going to do is you know that the number of states are Q0. 4 states will directly draw the transition table. The number of states are 5, Q0, Q1, Q2, Q3, Q4, where Q0 is my final state and also the initial state. I have to write the transitions for Q0 and 1. So the trick is you have to write Q0, Q1, Q2, Q3, Q4 in the transition table from top to right, top to bottom, left to right. You just fill it, you will get the transition. So for example, for this one, you will get it as Q0, Q1, Q2, Q3, Q4. You fill it as Q0, Q1, Q2, Q3, Q4. So how do we do that? You go in a zigzag manner. You complete one cycle, you start another cycle. So this is how you have to fill it. Top to bottom, left to right. You can simply get it and you can solve this question within a minute if you use this short trick. So this technique can be extended to any modulus. The modulus will tell you modulus n also, then you will have n minus 1 states. And the number system can also be n-ary number system, wherein you will have m-ary number system, where will you have m minus 1 symbols. Symbols will go till m minus 1 and there will be m symbols, right? Okay. So I hope the technique is clear to everyone. And with this, we complete our discussion on the finite automata. Regular expressions are left. We'll do some questions on regular expressions, but as far as the construction is concerned, we have discussed enough number of problems on finite automata. Right now, let's move to the next topic, which is grammars. The context-free grammars are the most important part grammars that we have in the GATE syllabus. Although other grammars are also important, but the most important one is context-free grammar, and more number of questions are asked on that. So we'll solve some 2-3 questions on context-free grammars, and then we will move to the regular expressions. Right? Let's see the context-free grammars. So I give you some 2 minutes to solve this question. Let's see. It's an MCQ question, so you should not take more than 2 minutes to solve this question. It's a very simple one. So you are incorrect, Hemashri. Just cross check once. Or okay, sorry. So yes, Kundan, I have unmuted myself. I've unmuted myself. So all of you are incorrect. The answer is incorrect. Just cross check. So Kundan says, "Are you from IIT, sir?" So yes, yes, Kundan, I am from IIT Bombay. I've done MS by research from there. Okay. Is it okay, Gagan? Is it audible now? Yes, Kundan, you are incorrect now also. It is not ABD. Read the question properly. Yes, Homashu, you are perfectly correct. Others, please cross check. Gagan says C, Kundan says C. All of you are incorrect. Why? Why it's so? Just cross check. Just cross check once. Saurav, you are correct now. It is a very simple question. I'll give you last 10 seconds to check this. Last 10 seconds. Abhilash, now you are also correct. Saurav, you are correct. And Hemashu, you are correct. What about Kundan and Gagan? Just cross check once. I'll answer it now. Yes, A is the right answer. So let's see how it is like that, why it is like that. So the language represented by the above grammar over the alphabet 0, 1 is. So now when we say represented, always remember that when something represents a language, the strings in the language should be accepted and strings not in the language should not be accepted. That's the main crux. And over here we see that this is basically producing all the palindromes, all the even and odd length palindromes, right? So this represents all palindromes, not just all odd length palindromes, not just all even length palindromes, right? So that's why the answer is only A, right? So 0, 1 is also generated. You can directly go from A to 0, 1, right, Kundan? So it represents all the palindromes, even epsilon is also there. So the answer will be A, right? What about strings not in the that begin and end with the same symbol? Although the palindromes have the property that the palindromes will have the property, just a second, the palindromes will have the property that they will start and end with the same symbol. They will start and end with the same symbol, but again, when we say starting and ending with the same symbol, there are some other strings also which needs to be generated. So therefore, this option is incorrect. So for example, let me take the example. The example is 0, 1, 1. let's say 100. This also starts and ends with the same symbol, but this language, this grammar does not generate this. So strings not in the language should be rejected, right? Did everybody got this point? So therefore the answer is A. This is a very simple question. Just you have to look at the keywords, right? Okay, okay. So yes, so B and D also. So again, it just does not represent. So when we say something represents, the grammar represents the language, this grammar is representing the language, all the palindromes, not just even length palindromes or not just odd length palindromes. Representation means all the strings in the language should be accepted and all the strings not in the language should be rejected. So the language is all the palindromes. If the question would have been the grammar includes, then the option will be A, B and D. When we say represents, then it has to be the exact thing, right? Is it okay, Gagan, now? Gagan, do you get the point? Right? Yeah, so let's move to the next question. Yes, Gagan, thank you for confirming. So let's hear you about grammars. Let me briefly summarize so that just to cross check that whether everybody knows about grammars or not. So we have some 4 types of grammars. Type 3 grammar, which is so I will briefly define the grammars within 1 minute so that the concepts are brushed up for everyone. Type 3 grammars are called regular grammars and their format is A goes to alpha B beta or A goes to B alpha beta, where alpha comma beta belongs to terminal star and where A and B are your non-terminal, right? And when we say type 2 grammar, we have that is known as the context free grammar. How does the format looks like? It is A goes to alpha. A goes to alpha, where A is a vertex or a non-terminal, alpha is V union terminal star. Right? Is it okay, guys? I'm just brushing up the grammars. Type 1 is context sensitive grammar. They have the format alpha goes to beta, where alpha belongs to V union terminal plus, both alpha comma beta belongs to V union terminal plus, and mode of alpha has to be less than equals to mode of beta. That is it should expand, right? And the last is type 0 grammar. The space is not there. Maybe I'll write it here. Type 0 grammar, which is unrestricted grammar. So for unrestricted grammar, the format is alpha goes to beta, but this restriction of expansion is removed and this restriction of V union terminal plus is also removed for alpha. For beta, so for beta it can be V union terminal star, and for alpha it is V union terminal plus. That's all. So that's all, right? So I hope you all of you could remember, memorize what are the various types of grammars that we have, right? So now let's see the next question on grammars. And as I said, the most important grammar is context free grammar. Therefore most of the questions that I'm taking will be based on context free grammar, right? Okay, let's see the next question. Yes, so another again 2 minutes for this question. So Gagan changed his answer for the third time. Gagan, are you sure now? So Kaushalya says D, Kundan says D, and Saurav also, Saurav says B. Just cross check. Saurav, just cross check your answer. So as I said, when a grammar is representing certain language, the strings in the language has to be accepted and the strings not in the language has to be rejected. That's the crux of this question. That's the crux of this question. Right? So Saurav says B, and Saurav just cross check. Okay, Saurav now also says D. Viram says, sir, my question. What is your question, Viram? Vikram says, sir, my question. What is your question? Okay, so meanwhile, let's try to see which one of the following grammar generates the language L, where L is a to the power I, b to the power j, and I is not equals to j, right? Now the option B is producing, so option B, what it will produce, from S it will produce AS, and then you can keep on producing AS or SB, but it does not tell you about the relation between I and J. So for example, I might end up producing S goes to AS, and then I produce S goes to SB, right? And from this SB, I can again produce another SB, and from this S I produce an A. So here the number of A's can be equal to number of B's also. So therefore this is incorrect. Is it okay? Right? So here this language S goes to AC and CB, right? So either AC or CB, and if you see this part C is helping you to produce equal number of A's and B's, and this will help you in producing an extra A or an extra B, right? So this will help you in producing an extra A or an extra B, and but what is the issue with this part, why it is not correct? That we have to find out, right? So why it is not correct? What is the issue with this? Why A is incorrect? For C it is very clear. I can also produce epsilon out of it. I will take S to AC. I'll take S to AC, and I'll take A to epsilon and C to also to epsilon. It also produces epsilon which has I is equals to J. In case of epsilon, I will be equal to J. Therefore, this is also incorrect. Now, what is the problem with this part? What is the issue? The answer is D, as you all correctly answered. So the only issue is this part. Can somebody point out that what is the issue with the first part? What is the issue? Why this is incorrect?
200.
Here,
Okay. So
number of A's can also be equals to number of B's.
that
See, let's see. When I generate S goes to AC, right? Now C can help me in producing more and more number of A and C, equal number of A and B's, but I don't use it. I directly go to B, and using an A, I will produce AA, and this A goes to epsilon. So now also number of A's are equal to number of B's. This is also incorrect. So only one option is right, which is D. Therefore answer is D. Right? Right? Everyone is fine with the solution. So the answer is D for this question. Right? So now let's go back to the next question. And this is the last question on context free grammars that we are doing. And I'll again give you some 2 minutes to solve this. Say, sir, every regular language is unambiguous. What do you mean by language being unambiguous? The question itself does not make sense. The grammar is either ambiguous or not. Language cannot be ambiguous. Maybe you need to frame the question correctly. Language is always unambiguous. The grammar may be ambiguous, unambiguous or ambiguous based upon whether you can make a single parse tree, or if you can make only a single parse tree for every string in the language, then it is unambiguous. And if you can make more than one parse trees, then it is ambiguous. So language is always unambiguous. Grammar may be ambiguous or unambiguous. The question is not correctly framed, right? So let's see the solution for this part. Himashri says D. Okay, let's see. What about others? So Kundan, your answer is incorrect. Just cross check once. Yes, Saurav, you are correct. Gagan, you are also correct. So Kundan, just cross check your answer. The answer has to be D, right? So let's see how it is D. So over here, if I see this language,
0, 1, 5 into 100.
And if you see this language grammar, S1 is okay. So it has to be S. Just a second. There is just a small typo. It is just S, right? So yeah, it's not S1. It's just S. Yes. So you guys use S only, is it? Gagan, did you use S only while solving the question? There was a typo in the question. Can you just confirm? Okay. So meanwhile, let's see the solution. So again, S produces AS or B. So right. So I can have. So if I directly take the root for B, S goes to B and then B only produces B's. It does not produce A. So my M can be greater than equals to 0, right? But N has to be greater than 0. Why? Because to get rid of S, I have to go to B, and to get rid of this B, I have to produce at least one B. So M is greater than equals to 0 and N is greater than 0. There is only one option which says this. Therefore, option D is correct. We do not need to check this, right? So we can just simply solve it by elimination. And that way we could also have saved some time in solving the question, right? Okay. Is it okay, everyone? Should we move ahead? So this was all about context-free grammars, and all the grammars and questions, as I said, are mostly asked on context-free grammars when we talk about grammars, right? So now let us move to the next topic of the day, that is regular expressions. We'll solve some 2-3 questions on regular expressions and see and just try to make sure that if the question comes on regular expressions also we can easily solve it, right? So let's move to the next topic. Okay, so here is the question and I will give you some 2 minutes to solve this.
Stressing, stressing. Okay. Now the tendon, because it is a linear profile, I told you, no, the tendon is 0 at supports and how much it is and varies with a linear value at midspan. In order to balance the external concentration load of 12 kilonewton, the required value of E. What is the value of E? So here we'll discuss this point very clearly, my dear students. Okay. So here what I would like to tell you here is there is a pre-stressing beam, mama. Okay, first of all, this is the neutral axis and we have the pre-stressing cable is theta 08 supports and 08 supports. So here we have a load that is 12 kilonewton. Here we have a load, how much sir? 12 kilonewton and here we have a pre-stressing force. So if I resolve these forces, amma, if I resolve these forces, if I resolve this, you will get pre. So if I take here, one thing is sure, sir, you will have a force due to one thing here and you will have. So can I write that this one is this force? Sir, are you getting me? There will be a vertical force due to this and this will be P sine theta, vertical force. And due to this also there will be P sine theta. So you can clearly say that 2p sine theta is equal to 2p sine theta is equal to what, sir? 2p sine theta is equal to 12 kilonewton. 2p sine theta is equal to 12 kilonewton. Or you can say the value of sine theta, okay, 2p sine theta is equal to 12 kilonewton. We'll because due to balancing, this is one point I would like to add. Now, theta, sir, tan theta is equal to L. Now, what is E? You can E is 2 is
So people say A, B, C, D. No, A, B, C, D is incorrect. Kundan, you are correct. What is the question? Which of the regulation represents the language AB such that no two A's are together? Okay. No two A's are together. All of you are incorrect. Just cross check once. Which of the regular expression represents the language over A comma B such that no two A's are together? Okay, Vikram, you are correct. Perfectly correct, Vikram. Kundan, you are incorrect. Just cross check once. So the answer is B and D. I'll explain now. We have given enough time for this. The answer is B and D. So again, guys, you can solve these questions with the help of the technique of elimination, right? You just try to see when we say a regular expression represents a language, that means all the strings in the language should be accepted and all the strings not in the language should be rejected, right? So now, why option A is incorrect? It produces B plus AB star. It is fine that no two A's will come together in this, but it will not produce the strings which are ending with A. So it will only produce, so are you getting my point? So the strings which are ending with A and no two A's are together, these kind of strings will be missed by this grammar, this regular expression. But when we come to this regular expression, this covers all the cases. Why? We have B plus AB star, A plus epsilon. So in this case, it is B plus AB star plus B plus AB star A. So now this part is producing, so this part and this part, both the parts are producing strings which does not contain two continuous A's, right? No two A's are together, that's fine. But this part will help you in producing the strings which are starting with A or B, but ending with, starting with A or B and ending with only B. And this part will help you in producing starting with A or B and this part as ending with A. So this is the complete answer. This does not produces these strings, right? Okay. Now, similar is the case for this language also. It is B plus AB star, B plus BA star, this is B plus BA star. Over here, this produces the string starting with A, this does not produces the string starting with A. Therefore, the answer is B and D only, right? All right. So let's see. Let's see the next question that we have. Which of the two regular expression represents the language over A comma B such that no two A's and no two B's are together? So some 2 minutes to you guys to solve this question. Sorry, now I've unmuted myself. Okay. So the answer is only C. Abhilash, you are incorrect. All of you tried. The first attempt of all of you is wrong. I'm not sure why it is so, but let's see the solution, right? So now, right? So option C is perfectly fine. Why? Because as we know that the strings have to have a combination of AB only. That is the only way we can avoid no two A's together or no two B's together. either AB or BA. The question is based on AB or AB, right? So this is perfectly fine. What are these two guys helping it? It is helping it to end with A. It is helping it to end with A or B. This is helping it to end with, start with, this is helping it to start with B or A. For this, so for this, again, this part is missing, therefore this is incorrect. For this, both these parts are missing, therefore this is also incorrect. Now for option D, so option D is completely wrong. I take AB, and then in the next iteration I take BA. Two B's are coming together, which is not the requirement. So the answer is C. So the answer is only C. Okay? Correct, Himashu, you are also correct. So now let's move to the next question on regular expressions. So again, the trick behind the MSQ based questions is you just try to eliminate the options. You keep on producing the strings in the language and see whether the regular expression is representing that or not. And while doing so, always remember one thing, that you have to have again, so while answering these questions, you always have to remember one thing while solving these kinds of questions, that the strings in the language should be accepted and strings not in the language should be rejected. That's the only trick. You keep on trying the things, right? Right. So here is the next question for you guys. Which of the regular expressions represents the language over A comma B such that the strings contains B? So I'll give you another 2 minutes to solve this. And this is the last question probably on regular expressions. Then we move to the next topic. So Kundan says, how much is needed for IIT Bombay for CSE marks? Okay, Kundan, it depends from year to year. We cannot predict it. Once the paper is out, we can tell you. You just focus right now on scoring as much as possible. So the cutoff vary from year to year. So there is no one single answer to this question, right? So just focus on the marks right now. We'll do the counseling once we have your marks, where to join and where not to join. Yeah. So let's see. So Kundan says ABD, Gagan also says ABD. Let's see. What about others? So I think we have already given 2 minutes. Let's solve the question. Which of the regular expressions represents the language over A comma B such that string contains B? So again, this contains B and there can be anything A plus B star. This is perfectly fine. This contains B and this can be A plus B star or A star. This is also fine. Now this contains B, this is A plus B star or A star, this is also fine, but this is a problem. This means that only one B, but the requirement is it at least contains B. Contains B can have more than one B's also. So therefore the answer is A, B, D, right? Right? Is it okay? So now let's move to the next topic. So this is all about regular languages, regular expressions, and the only thing that you have to keep in mind is use option elimination method, and keep in mind that the strings in the language should be accepted and strings not in the language should be rejected, right? Now let's move to the next question. So next we have is push down automata. I'll briefly define push down automata to you guys, and then we will see, well, we'll solve some questions on one or two questions on push down automata. Let me briefly define what push down automata is. It gives you the functionality. We'll quickly revise push down automata in 1 or 2 minutes, and then we will solve a question on that, right? And again, so let us define push down automata. So push down automata has Q, sigma, delta, Q naught, F. I'm talking about push down automata. Along with this, all these are similar. The delta function changes will define what delta function is, and then we will have something called Z naught, which is the bottom of the stack. That is bottom of the stack. And then we also have one more thing, which is the stack alphabet. One more thing, which is called the stack alphabet. So the 5 tuple becomes a 7 tuple because we have added the functionality of the stack, which is Z naught and tau are representing that functionality. Now what is my delta? Delta now becomes Q cross sigma cross delta, cross tau. It has to be tau. Cross tau. So cross tau, it goes to Q cross tau star. So the delta function becomes this, and if it is, this is for DFA, for deterministic push down automata. If I make it as non-deterministic push down automata, the delta function looks like Q cross sigma cross tau to 2 raised to power Q cross tau star. So there is one mistake, sigma union epsilon is also included. Over here it also has to be sigma union epsilon. So this is how we define the transition functions for DPDAs, and this is the transition function for NPDAs, right? So this is briefly what is push down automata is, and so for your ease I will draw one, just a second. Okay, the PDA has not appeared. I drew the PDA, it is not coming up here. Okay, so what we will do is, just a second. So over here, let us see how the PDA for A raised to power n, B raised to power n looks like, and then we will answer the questions that we have. So for A raised to power n, B raised to power n, what we will do is we will keep on pushing A's until they come. If it is Z naught, sorry, the top of the stack is Z naught. The top of the stack is Z naught. Then you will push A Z naught. And if the top of the stack is A, you will push AA, right? You will push A's. So once you get a B, you will start popping. So you will start popping. For A, you will put epsilon, and for B, A goes to epsilon. And if the B's keep on happening, B keeps on coming, you will keep on popping all A's. And at the end of it, if all A's are popped, then you will have epsilon on the input. You will have Z naught on the top of the stack. You will again push back Z naught, and you will go to the final state. So this is how you draw PDAs. The first symbol represents your input, whichever you have read. The second symbol represents the stack top, and this represents what you do on the stack. So stack operation that you have to do, which is your tau star basically. Right? So this is how you draw DPDAs, the PDAs, right? And this is like acceptance by empty stack, acceptance by final state. You can also have acceptance by empty stack also, wherein I'll just change it in this itself. You can note it down. So this is your PDA, acceptance by final state. But if I want acceptance by empty stack, I'll simply remove this part, and then over here I'll have another transition which says epsilon z naught epsilon comma z naught goes to epsilon. So now your stack is empty, even it does not have the z naught with itself. Therefore it is the acceptance by empty stack. This is acceptance by empty stack. So the one in greens is acceptance by empty stack, right? So this is acceptance by empty stack, right? So if you know these questions, the questions can be based on the missing transitions that you have. We'll do just one question on this, and then this is all about PDAs, right? So let's see one question on this, and somehow what has happened is the PDA which I drew is not here. Anyways, I'll draw the PDA for you guys once again. So this question says the PDA given below represents the language over A comma B such that the number of A's is equal to the number of B's. The missing transitions are. So right. So here is the PDA which I am trying to make, and then I'll tell you what are the missing transitions. I drew it somehow. I don't know why it's not here, but let's see. I'll make the question right now itself. So here we have, let's say this is your, let's say this is over here. We have A. On A, if the top of the stack is Z naught, you will make it A Z naught. If the top of the stack is B Z naught, you will write it as. So these are the transitions for this symbol. For this transition, B Z naught. And if it is epsilon Z naught, epsilon, and if it Z naught comes, I will say that keep it as Z naught. So now some 4 transitions are missing. Some transitions are missing here, and tell me which of these are missing. So you tell me the transitions for this part. So yeah, so this is the complete question. Somehow the diagram did not come up. So the automaton did not come up. Now can you solve this? So the question is PDA given below represents the language over A comma B such that the number of A's is equal to the number of B's. The missing transitions are. You have to tell me these missing transitions, and it's an MSQ based question. Right? So DPDA close and so Vikram says, sir, DPDA is closed under complement. Sir, can we, can we produced complement language converting non-final to final state, same as DFA? Yes, definitely you can do that, Vikram, but you have to ensure that the DPDA that you have is a minimal DPDA. If that is the case, you can do that. There is no issue. And mind you that the condition should be acceptance by final state. If that is the case, then you can do that. If the DPDA is made based on that the acceptance is by final state, right? Okay. So now everybody has given the right answer. It is A, B, C, D. All of them needs to be done. So the PDA given below represents the language over A comma B, that number of two. So for example, if A's are coming, and we already have an A, you keep on pushing A's. If B's are coming, you already have a B on the top of the stack, you keep on pushing B's. But if there is an A and on the top of the stack is a B, you abstract it out or you pop it out. If it is a B on the top of the stack, you have an A, you abstract it out, you pop it out. So this way, if at the end of the stack, if at the end all of the symbols are exhausted and you reach epsilon, if you reach epsilon and the top of the stack is Z0, then you know that the number of A's are equals to the number of B's, and therefore A, B, C, D is the right answer. So right, so similar questions can be asked on PDAs. They can give you a PDA and they can ask you simply that what are the missing transitions, right? So they can draw the PDA and they also have to explain the notations behind that. So I have not given the notations in particular because I explained the notations just before that, but in general, if the question comes like this, they will explain the notations properly, that how the delta is represented. What is Q, sigma, delta, Q naught, F, they will all represent everything and then they will ask the question, right? So now by this we move to the last topic of the day, that is Turing machines. Again, the questions can be of the similar type. What they can ask is again the missing transitions, and we should know how to draw Turing machines. What I'll do is I'll draw one Turing machine now and then tell you how the questions can be, how the variations can be on Turing machines, how they can ask questions, right? So let's draw the Turing machine for A to the power n, B to the power n. Maybe all of you can draw it and I'm also drawing it parallelly. So let's see, let's just brush up what Turing machines are and what are the kind of questions that can be asked. I'll just simply define that how the questions can be on Turing machines. So by that we will be able to complete all the kind of questions that can, all the major types of questions that can come from Turing, from the theory of computation. So let's move to Turing machines. So Turing machines, again let us define the delta, the tuple. The tuple is a 7 tuple. What do we have in Turing machines? We have Q sigma delta Q naught F. So Q sigma delta Q naught F. Apart from this, we have a blank symbol. We have a blank symbol on the tape, and also we have tau, which is known as the tape alphabet, which is the tape alphabet. And the transition function delta for deterministic Turing machines. So Q is same, sigma is same, delta is same, Q naught is same, F is same, which we used to have in earlier notations also, in other automata also. B is the blank symbol and tau is the tape alphabet, right? Now what is delta? Delta will now take you from Q cross tau to Q cross tau to Q cross tau cross right or left. This is one change. And when you have non-deterministic Turing machines, the delta changes a bit, which is Q cross tau to Q cross tau 2 raised to power Q cross tau cross RL. So this is the only change when we come from non-deterministic to deterministic, right? And this is for deterministic, right? So this is how the Turing machines looks like. And let us draw one Turing machine and I'll tell you how the variations can be in the questions for Turing machines. The similar questions as we did in DPDA, in the pushdown automata, similar kind of questions can come from Turing machines also. They'll draw the Turing machine and they will miss certain transitions, and then they can ask you what are the missing transitions. So that is how the variation can happen in a Turing machine. So we are above time. I'll just take some 5 more minutes to define how to draw a Turing machine, and then we will close this session. Just wait for 5 minutes. So how do we draw a Turing machine? Let me add a new slide. So yeah, I'll write here the Turing machine. I'll draw the Turing machine for A to the power n, B to the power n. How to draw the Turing machine for A to the power n, B to the power n? Let's draw the Turing machine. So so again, in the beginning, what I can get is if I get an A I'll keep on replacing that x, a with an x, and then go right, right? So the string will be, let's say, a, b, b. Let's see how do we accept this string using a Turing machine. Although we know that a to the power n, b to the power n is a context-free language, and we can accept it using a PDA also. Let's see whether Turing machine also accepts it or not, right? So how do we see that? So let's see this example and then see whether we are able to draw the Turing machine for this. Now we see that on a, I replace it with x and I move right. Now I have replaced it this a with x and I moved right, and then all the a's which come on the way, I will keep on replacing them with a's, and I will keep on moving right. This is a transition for this. And once I reach a b, I'll replace the b with a y and then I'll start moving left. I'll replace it with a y and I'll start moving left. This is how we draw it. And then over this state, we know that we have seen b. Now I am in the search of another a so that I can match it with a b again. So now what I'll do is I'll keep on replacing all the a's that I get on the way with a's itself, and I will keep on moving left, right? So I'll keep on moving left, and when I reach x, I get to know this is the last a which I have seen. I will come to the initial state. I'll write it as x is replaced with x and I will start moving right. So now I am standing at this position. Now again, if an a comes, I'll replace it with an x and I'll start moving right. Over here, I have written that I have to replace a with an a and I have to move on right, but I got a y also. For y also we'll do the same thing. For y, we'll replace it with y, we'll keep on moving right. So these two are for this transition, not for the bottom guy. This is for this one, right? So now I get a b, I'll replace it with a y and I'll start moving left, right? I have exhausted all a's and b's. Let's see. Now when I start moving left, I earlier wrote that I have to replace a's with a's. I also have to replace y's with y's and I'll have to keep on moving left. Right? So now at this state, I have started going left. I reached here and I found an x. And I have moved to this place, right? So I am right now standing here and I have seen an x. Now over here I have written the transition for a. I have not written the transition for b. How will I write the new transition now? Let's say, so now this is the case when we have exhausted all a's. Now what we will see that we will see a y. If you see a y, keep on replacing it with a y and then you keep on moving right. So the string is a, b, b, and we have blanks after that, right? So now once you reach this state, you keep on replacing y's with y's and you keep on moving right. Why you are doing so? You are exhausting all already seen. You are exhausting all the already seen b's. Now at the end of it, if you find a blank, you replace it with a blank and then you move either right or left, it does not matter, you reach to the final state. So this at this state, number of a's will be equals to number of b's, right? So what they can do is they can give you a Turing machine, they can draw some parts of it, then they can ask you the missing transitions. So for example, they might omit all this and they might omit all this. So they might omit all this and then they can ask you the missing transitions as I asked you in the DFA also. So you should know the technique behind making Turing machines. We made one of the Turing machines and similarly you can make other Turing machines also, right? So this is how we make Turing machines, and I hope if the question comes on Turing machines, you will be able to handle all such kinds of questions too, right? So so the guys, this completes our discussion on theory of computation. We have talked about identification of the class of the language in detail. We have done a number of questions on that and we expect always one question at least on that part. We have covered closure properties and also decidability and undecidability. We always expect a question on that. That is another part that we have discussed, and including all these three parts, we expect at least 2 to 3 questions. And the remaining parts which I discussed today, that is finite automata, deterministic, the push down automata, and then we discussed Turing machines, regular expression, the grammars. All of this together makes either 1 or 2 questions. So overall we will have some 4 to 5 questions from Turing, 3 to 5 questions from a theory of computation, which is an average, right? So I hope all of you enjoyed the session, and you could understand the kind of questions, what are the most probabilistic questions that can be asked from theory of computation. So the questions will be of similar complexity that we discussed, and hopefully maybe lesser complexity, but yes, these are the kind of questions that we can expect from theory of computation, right? So this completes this session, and so before we leave, let me announce the next session that we have. The next session is on compiler designs, and I'll be taking that session on compiler designs. And so I'm coming live again on 29th of November from 6 p.m. to 9 p.m. and over there we will discuss the most probabilistic questions that can come through compiler design. So yes, so see you all again in the sessions on the session on compiler designs. That's all from my side today. Yeah, thank you so much. Yeah, yes, Kundan, thank you Kundan. Yeah, good night. Yeah, thank you Abhilash, thanks Gagan, thanks. Yeah, thanks Vikram, thanks.